Welcome to the Explainer. So here's a big question. How do you bring cutting-edge tech skills to students in places that are often left behind? Today, we're going to do a deep dive into this really innovative program called CODERS that's trying to do exactly that, bringing computer science right into rural classrooms.
So here's how we're going to break it all down. First, we'll look at what CODERS actually is. Then, we'll get into how their method works. After that, we'll check out the data to see if it's having an impact. And finally, we'll talk about what this all might mean for the future of learning.
All right, let's get right into it. Part 1. What is this CODERS program anyway?
This is the fundamental challenge they're tackling. CODERS, which stands for Computer Science Opportunities, Development, and Education in Rural Schools, was built from the ground up to answer this very question. It's an initiative run by Missouri State University, and their mission is pretty clear. Get computer science and something called computational thinking into classrooms for kids from 3rd to 8th grade. It's all about giving both the teachers and the students the skills they're going to need in our tech-driven world.
Okay, so that's the what, but the really interesting part, the part we need to understand, is the how. How exactly does CODERS go about empowering these teachers and engaging these students? Well, the whole program is built on this one core idea: computational thinking. Now, that sounds pretty academic, right? But it's actually simple. It's just a fancy way of saying learning to solve problems the way a computer would. Take a big, messy problem and break it down into smaller, logical steps. And here's how they make that idea click for the kids, which I think is just brilliant. They use a super simple analogy. They say, hey, writing a computer program, it's basically just like writing down the super detailed instructions for making a sandwich. Every single step has to be perfect. And this process they teach, well, it covers the whole shebang. You start by figuring out what the problem even is. Then you brainstorm some ideas, you outline your steps, and then you finally get to the coding. But it doesn't stop there. You have to fix all the bugs, make it better, and then show everyone what you made. And of course, to make this all real, they get to play with some seriously cool stuff. We're talking hands-on tech like these programmable cute bots and microbits, quirky little robots and controllers that really bring all that code to life.
And the projects themselves sound like an absolute blast. I mean, just look at some of these names. Case of the Rotund Rodent, Robot Dog Treasure Hunt. They're programming robots to get through mazes, go on scavenger hunts. They're even working with drones. It's all designed to be super fun.
Okay, so fun projects, cool robots, it all sounds great. But here's the million-dollar question. Does any of it actually work? Well, lucky for us, we've got the program's own evaluation report, so let's take a look at the data. Well, okay, the first number that just leaps off the page is this one, 42%. That's a 42% increase in the number of students who scored proficient or higher in science. I mean, that is a huge jump. And if we break that down a bit more, you can see that massive gain in science right there. Math proficiency also saw a really solid 10% bump, but, and this is really important to see, it wasn't all positive. English and language arts scores actually dipped just a little bit. Now here's a finding that's kind of fascinating, a real head-scratcher. While the students actually felt more confident in their math skills after the program, their overall interest in coding went down, just a little. It's a weird little wrinkle, and the report says it's something they need to research more. And it's also worth knowing who we're talking about here. The vast majority of participants, nearly 70%, are middle schoolers. And that's such a critical age, right? It's when an interest in STEM can either really blossom or just fade away. But this isn't all about test scores. You've got events like the annual Coding Olympiad that really show the human impact. They push these students with some really tough but fun challenges, and the kids talk about feeling this incredible sense of accomplishment when they finally crack it. And honestly, nothing speaks to that impact more powerfully than this one quote. After the 2024 Olympiad, a student wrote, "For the first time ever, I felt somewhat smart." Just, wow, that really says it all. So, what's the big lesson here? What's the major takeaway from all this? Well, the CODERS program seems to be telling us that the future of STEM learning is about a whole lot more than just writing code. Because here's what makes this program so unique. There's a huge emphasis on integrating writing and communication right into the engineering process itself. It's about structured thinking and learning through trial and error. The students use this thing called an engineering notebook to write down everything.
every single stage of their journey, from identifying the problem to brainstorming to research to sketches, even daily logs. It forces them to constantly explain the why behind their choices.
And this whole process embraces a powerful concept called productive failure. The idea is that it's not just okay to make mistakes, it's a planned and essential part of learning. They want students to experiment, fail safely, figure out why, and then try again, documenting it all. So here's the bottom line, which you should really take away from this. The CODERS model shows us that teaching skills like resilience and communication is every bit as important as teaching the code itself. By combining those technical skills with a mindset that values iteration, you're not just making coders, you're preparing students for real-world challenges.
And that kind of leaves us with a big question to chew on, doesn't it? As technology gets woven deeper and deeper into our world, what skills should we be prioritizing in our schools? Is it the technical stuff, the creative, something else entirely? How do we best prepare students for a future that we can't even really predict?